how to calculate heat removal with an air heat exchanger. We're going to use air to cool a hydraulic system. So the calculation is based on air temperature, on ambient temperature. So let's say that you have a hydraulic pump and you have an electric motor. This can be an engine for mobile application. Industrial application, if you have an electric motor, so that's your electric motor right there. Let's say the pump is a 50 GPM pump and you have a motor that has 70 horsepower installed. And you have a fluid going into the system. And let's say you have the system up here, and at the return line, you have a heat exchanger. As your heat exchanger right there. Let's say it's some air heat exchanger. And let's go back to the reservoir. So then you need to have your maximum temperature, system temperature, and your maximum or your ambient temperature. What is the maximum ambient temperature that you have? Always go with the maximum ambient temperature. So in that case, you take into consideration the worst situation. So let's say ambient temperature is going to be, let's say, 100 Fahrenheit. And let's say maximum maximum system temperature. Let's say max system is going to be 160 Fahrenheit. So with this information over here, you have all the information that you need to calculate a heat exchanger. In this case, we're doing air. So that's why we have ambient temperature over here. If we are doing water, so you need a different calculation that goes right into the plate heat exchanger, and you take into consideration water temperature and all that. But this is going to be with air. So in this case, there's different methods on how to do it. The method that I do it, the one that I prefer, is taking in consideration the installed horsepower. Why? Because that's the maximum installed power that we have into the system, and 25 to 30% of the horsepower can be translated into heat into the system. So what I normally do, I'll say 70 times 0.3 equals 21 horsepower. 21 horsepower, that is the magic number that we're going to use. And this works with an air heat exchanger or water heat exchanger. That's the magic number that you would need to remove the horsepower. Now, I've seen people using 0.4. I've seen people using 0.5. On this example, we're going to use 0.3. So 21 horsepower. Now, we need to find out what magic number do we need to get to get to the heat exchanger. So I need to translate the 21 horsepower into units that I can work with. Many heat exchanger manufacturers may have their units on measuring kilowatts. Others have it in BTU. I'm going to use BTU an hour, which is the one that I use, So I come on and I say 21 times 2546 that is equals to 53466 BTU an hour. Now that I have the BTU, I need to divide that number by the temperature differential that I have between ambient temperature and maximum system temperature. So in this case, I go 160 minus 100 equals 60. That's the temperature differential number that I'm going to use. So I go down on the equation and I say 53466 divided by 60 equals 891.1 BTU per hour per Fahrenheit. Now this number right here, that is the one that I need to find in the literature of the heat exchanger. In this case, is going to be an air heat exchanger that I need to remove. And I need to find a unit that can do at least this heat removal and that can handle 50 GPM. Or I would say, in this case, I'll say 50, but keep in mind that in the return line, if you have cylinders that are too big of cylinders, you may have a higher flow than what the pump is coming out. So you may need more than 50. You may need, I don't know, depending on the calculation of the cylinders and the areas, you may have 60, you may have a higher GPM coming back. So let's say 60 GPM, just for reasons of this exercise. So the units that I'm going to need, let's say 60 GPM that this heat exchanger can handle with a heat removal of 891.1 BTU an hour per Fahrenheit. So that is the calculation on how you go about to pick a heat exchanger, an air heat exchanger, to work in this application. And like I say, this is for an air heat exchanger. If it's a water heat exchanger, that's a different story. You have to have water temperature, oil temperature, and see how much the cooling come out to be on the heat exchanger. One thing in common that both calculation both calculation have in common is going to be the horsepower removal. So when you think about how much heat you need to remove from the system, always think about how much horsepower you need to remove from the system and how much horsepower is installed in the system. So that is the way that I go about to calculate a heat exchanger, an air heat exchanger. And yeah, that's the video for today. I hope you like it. You can hit a like, you can hit subscribe, and we'll see you next time. Have a good day. Bye-bye.